Where's the kid?
That's what you're supposed to know. We literally did one of those yesterday.
I was paying attention, but I forgot.
Well, pay attention when we go over it today. Maybe take some notes if you need to. Maybe watch the video that I'm going to record. Your choice.
What's the name? What's your YouTube page?
I've emailed it multiple times to the class.
I don't check my email.
Well, fix that. Okay. This is a lot more important. Thanks, sir. Okay, real quickly. Couple things, legitimately. One, check your email, right? I told y'all this before. The main way I'm going to be communicating with you is via email. The reason for that is, y'all are in high school, okay? And if you go to college, you're not going to get remind texts. You're going to get emails. So we need to start practicing getting ready for that. Two, if you go to a professional setting, the main mode of communication, actually there's two. There's things like Slack, which is a collaborative learning space, which I would love to do that, but then there's also email. Those are the two main ones, things like that. So we're going to use email to communicate. That's how I'm going to communicate. So you need to make sure that I have a good email for you, which actually I think Gabe, your email keeps kicking back, so I need you to give me a different email or maybe rewrite it to make sure I have the right email address for you. Huh? You what? No. I'm sending you emails and it's kicking back. You're never getting them.
I don't need your mine either.
Well, then you need to give me an email that you actually will check. Okay? So, that being said, check your emails. That's how I'll communicate. That's how I will send out information about where the YouTube channel is. It's I have a separate playlist just for geometry. Okay? So let's look at this though. So I just asked create any equation that is equivalent to c equals 2 pi r. So this first one here, we went from c equals 2 pi r to c plus 4 equals 2 pi r plus 4. Do you think that's equivalent?
Yeah.
Why do you think it's equivalent, Jalen?
They add both to, you add 4 to each side, so it could be the same answer.
You added 4 to each side, so it gives you the same answer? What is that called?
Equivalency.
Well, they're called equivalent equations, yes, but what are you using that's creating those equivalent equations? Not commutative property, we'll come up to that in a second, is one of the properties of equality, okay? The idea of whatever you do to one side, you have to do to the other, that is a property of equality. Which one are we using here?
Addition.
Addition, right? It's not a trick. We added 4 to both sides, so what is it?
Addition.
Addition, property of equality. We good with that? What do y'all think?
Yeah.
Yeah, okay. Let's check the second one here. Then we got 2c is equal to 4 pi r. Is that equivalent to c equals 2 pi r?
Yes.
Raise your hand if you agree with Jalen that you think it is equivalent.
Wait, what?
Is 2c equals 4 pi r equivalent to c equals 2 pi r?
No.
Why do you say no?
Because
No,
they're
yes.
the same on both sides.
So something wasn't done the same to both sides?
Oh, yeah, it is.
Two is different from the 4.
The 2 is different from the 4, but Kelsey, what are you thinking?
Multiply both sides by 2.
So if I get 2c here, that means I multiplied by 2, correct?
And then 2 times
And-
the other 2, that make it right.
2c,
That's
would that give me 4 pi r?
Yeah.
Yeah.
So is that equivalent?
Yeah.
Yeah. So Ireland, it's not about the 2 and the 4 being the same. Is what was done to both sides of the equation the same? Multiplied by 2 is what gave me 2c, right? Multiplying by 2, what is 2 times 2?
Oh.
4, right? So are those two equations equivalent? Yes, very much so.
What
Is that-
property is that?
Yeah, that's a good question. What property is that?
Multiplication property?
Property of equality.
It is a property of equality. Why do we know it's a property of equality?
Because you're using the multiplication.
It was done to both sides of the equation, right? To maintain equivalency. Specifically, what was done to both sides?
Multiplication.
Multiply. We good with that idea? So just be a multiplication property of equality. All right, let's check this one. We'll check 2 more. 5 plus 2 pi r plus 2 is equal to c. What do y'all think?
I'm looking at.
That's this one right here, okay? Is that equivalent to c equals 2 pi r?
Yes.
No.
Why not?
Because you're not using 5 for both sides.
They forgot the 5.
On
Add
that
5 to the.
Okay, 1, those are 2 different numbers, right?
Yeah.
But more importantly, right, it's not just 2 different numbers. Did they add it to both sides?
Nah.
No, they added 5 to the left side and they added 2 to the left side. What would I need to do to the right side to make this equivalent?
Add 7.
Even though those aren't the same numbers, is that equivalent?
Yeah.
Is that equivalent? I hear Jalen saying yes, Alana saying yes, Austin saying yes.
Show.
Show you? You don't agree? You don't think it's equivalent?
I don't know.
You don't know?
Show.
Claire, how much did we add? So like originally we had 2 pi r, right? So how much is being added to that 2 pi r right here? That's a total of 7, isn't it? So even though I didn't write it as plus 5 and plus 2, am I adding 7 to the right hand side? So I added 7 to both sides? So is that equivalent? Yes. Does that make sense? Again, can it look different? Yes. Is it doing the same thing? Yes. That's what we want to focus on with the idea of equivalency. Brooke, you good with that? It looks like you're... okay. Last one I want to look at is this one right here. C times 4 is equal to pi times 2 times r times 4. Is that equivalent to the c equals 2 pi r?
Yes.
Yes.
Why do you say no, Matthew?
Because, wait, no, never mind. I didn't see 4. I didn't see the C.
Okay. I heard a couple people say yes it is. Yeah? Rose, why do you think it's equivalent?
Why you not calling me?
Because you said yeah.
You say yes too.
Okay, Zaria.
Me on the spot.
Zaria and Rose, help us out. Why do you think this is equivalent?
I'm just getting
No ma'am, you are here to think.
I am thinking.
Then tell us what you're thinking about.
Yes, I'm thinking.
Okay, times 4 on both sides.
Okay, we are multiplying by 4 on both sides, correct? So multiplying by 4 here and by 4 here. However, I do want to point out, hold on a second, that's 2 pi r times 4. Well, it is an 8, but notice how we have the 2 right here? Do these look exactly the same? Like the left-hand side looks the same. Does the right-hand side?
Yeah.
No.
Yes.
No.
No.
So are they equivalent still?
Yeah, it means the same thing.
How do you know they mean the same thing? Like I want to point out, first off, what property are we using up here? What property have we used so far?
Multiplication.
Multiplication,
Property of equality.
property of equality. Multiply by 4 on both sides, correct?
The pi
Yeah.
2 and r is pi 2.
The pi 2 and r are still being multiplied, yes, but does anyone know what property we can use here to show they're still equivalent?
Fill in the variable.
See how the 2 and the pi moved? They switched places with each other? That is the commutative, right? So I really like this one. I don't know if this was what that person intended, but notice they actually used 2 different properties to create an equivalent equation. They used a multiplication by 4 property of equality, and they used that commutative. And as long as they use 2 of this 2 properties that create equivalency, that's okay. Those are equivalent equations. Those look pretty darn different from what they started at. But are they still telling the same story?
Yeah.
Do we understand equivalency a little bit better, hopefully? Yes? Ready to move forward? Alright, so the next question is create an equivalent expression to 3x plus 4y minus 5x plus x squared minus x squared. Okay? We have a few different answers here.
Somebody put 4, 5, 6.
Okay, why are you laughing at that, Kelsey? Kelsey, why are you laughing?
Oh, I don't know.
What you laughing about?
I don't know.
Oh, I'm gonna laugh at someone, but I don't want to talk about it.
1, 2, 3, 4, 5, 6.
Okay?
What?
What? What'd you, that's something
So, Terrence, did you put 4, 5, 6?
No, I ain't put it.
I mean, I was just asking.
I put the one that say.
Here's the thing. I saw actually more answers like that than you would think on the quiz. We need to learn and pay attention to, we need to learn from this and pay attention, right? What is happening in this expression? Or, actually, let me say it this way. Ooh, let's talk about this one real quickly, actually.
4, 5, 6.
Okay? We had 3x plus 4y minus 5x plus x squared minus x squared. And all I asked you to do was to simplify, or to create an equivalent expression. There's lots of options. Is this one of those options? What does it look like they did? It looks like they used a commutative property. Did they do it correctly?
No.
Then
It's supposed to be a negative 5.
Notice how the 5 was subtracting, so it would be a,
It would have to be
it would have to be a negative 5x, and the 3x needs to be adding. See how that 3x is positive right there? That's very, very close. That was almost a great use of the commutative property, but notice that we need to keep our signs with our numbers. It's a positive 3x, it's a negative 5x. We good with that idea? Okay. Really quickly, right here, what does it look like this person did?
I have no idea.
No idea?
It's just no, it's, huh? Yeah.
It looks to me like everywhere there was an x, they substituted a 2 in.
That's right.
And where there's a y, they substituted a 4. Does it tell us that x is 2 and y is 4?
No.
Do not just randomly put a number in for a variable. You have to know, you have to be told x is 2 in order to substitute 2 in. Or you have to be able to solve an equation to figure that out. So please be aware of that. It's a great start, but not quite. Okay. Let's look at this one. 3x plus 4y minus 5x. Is that equivalent to what we started with? Why do you say no, Matthew?
Because
I guess.
there's no x squared.
There is no x squared. Yet, Jalen, you still say it's equivalent. Why?
Because the x squared, one positive, one negative, so they're going to cancel each other out.
Let's work on the language a little bit. Really quickly,
course.
what is x squared minus x squared?
0.
That's what you mean by cancel each other out, right?
Yeah.
Matthew, do I need to show that 0 that I'm adding? So are these equivalent?
Yeah.
See how that just created a 0, right? We added those like terms together. So, is that one good?
There you go.
Yep. Okay. Last one?
Top one.
That negative 2 went up above it. Okay, no.
Down,
Down.
down.
2x minus
No.
4. X squared minus
Yes.
That one? Okay. So x squared minus x squared plus 5x minus 4y plus 3x. Y'all think that's equivalent?
You flipped it.
Well,
Or they did flip it.
The 5
Ooh, the 5 is supposed to be a
negative.
negative.
And the
Is there
4 is
anything
supposed
else?
to be a positive.
Ah, and the 4 is supposed to be a positive. Would that be equivalent now?
No.
Yes.
Wait, is it?
Yeah, now it would be, right? So what properties are we using there to create an equivalent expression?
Community.
That commutative property, right? Notice lots of commutative is going on, but we have to pay attention, be careful about the positives and negatives. Does that make sense? We good?
Yeah.
Alright, last one I want to look at, this very top one that 2 different people got.
Who copied my house?
Okay? So we originally had 3x plus 4y minus 5x plus x squared minus x squared. And then this one that has 2 is negative 2x plus, actually let me put it down here. Would one of the 2 people who came up with that expression care to explain what they did? What you got, Jalen?
Okay, so like,
P.S. Who was the other one? Rose? Okay. What you do, Jalen?
so negative 5 minus negative 3, right? I got negative 2x. And like you said, the 2
Wait, so you took this 3x
minus, yeah.
and you subtracted that 5x from it?
Yep.
Why are we allowed to do that?
Because it's the same variable.
They have to.
It's the same variable.
They have the same variable. Okay, sorry. I need you to take your headphones out. They have like terms, they have the same variable. Now I want to be careful because I did notice, where was it? 8x. This is a very common thing that I see students do. Do you know where this student got 8x from?
We got 3x plus 4y.
Yep, still got 8x plus 4y plus x squared minus x squared. Where do you think they got 8x from?
Plus 5.
Huh?
So 3x plus 5.
Please notice, this is usually what students accidentally do. They add 5x, which that creates a what?
A positive.
No.
Oh.
That creates a what?
Zero.
A 0.
It can't-
But then they added 5x over here. Can we do that?
No.
No?
No, they're trying to use what? They're trying to use the addition
Property.
property of equality. But an addition property of equality is for
Equal signs.
equations. Do you have an equation here?
No.
So you cannot use an addition property of equality. That's why it's important to understand the correct language with that. You can only use an addition property of equality if you have an equation, right? That is important. So please hear me very clearly. If you made that mistake, fantastic. I'm glad you made that mistake because that's a chance for us all to learn together, right? That's a great mistake to make. Let's learn from it. But we want to recognize that I can do 3x minus 5x. Now, a little bit clearer explanation is this. What property did I just use?
Commutative.
I just used a commutative property, right? So that I could put my like terms together. Now it's a little bit easier to see. What is 3x minus 5x? Negative 2x. If you want to help make sure that you see it, use your commutative property to put like terms together. That's negative 2x. Is there anything else up here that I can simplify?
Like I did the last 2.
The last two, x squared minus x squared is?
0.
So I'm just left with negative 2x plus 4y. Are those equivalent? They look different, don't they? Do they tell the same story?
Yeah.
Math is all about telling stories. Alright? And that's what we want to pay attention to. Are they telling the same story? Alright, we are getting close to being done with equations and inequality, or we're just doing equations, which I know y'all are excited about. But we have a few more days left of this. And to get us started, we're actually going to look at where we stopped yesterday. Right, so I believe we were wrapping up 8.3, number 2. And we were looking at everyone's work with this, so please get 8.3 out.
Wow.
Okay, so remember we're on 8.3, number 2.
Ah.
There's the filling and emptying tanks. Nope, it's this one.
Yeah.
This again, I lost it. Oh, I'm sorry.
If you look on the back, there's number 2 on the back.
Again, I look on binder.
Where?
Downstairs at port 2.
Do you need one as well, Bashar? Man, y'all better be glad I print extras of these out.
I don't want to
Can
do
you
it
pass these
again.
back?
I don't want to do it again.
Alright, so please remember, okay, what I have written up on the board right now, hey, please listen, is what I've written up on the board right now, what Mr. Kinney created? No. I believe this table right here was this Zaria and Rose working yesterday, is that right? This strategy, I believe, was this group 4? Who was this? That was group 3? Okay, so group 3 came up with this strategy where they found the difference, and we also talked about something similar in this group of realizing, okay, it was one of the groups. Okay, in order to get to 151, I had to add 27 to that 124, stuff like that. So these are strategies, these are approaches that you came up with. Put the drink away. Y'all, really quickly, unless it's water, we don't have it out in my class. Oh yeah, please toss that as well. Unless it is water, we don't have it out. Too many things get dropped on the floor and get spilled. We don't play that game. I don't like cockroaches in here, so don't bring the drinks in. Put it away, put it in your backpack. Thank you. All right. So what I do is I ask you to engage in a problem. I ask you to think about it, to play around with it, to come up with some ideas. Then I'm going to pull different people's responses up on the board, whether it be here or it be on the chalkboard or whatever. I'm going to have you look at each person's or each different group's responses. And we're going to sequence them so that everyone can build up to the way that I was trying to get you to see it. Okay? So are all 3 of these valid? Yes. Heck, is it okay even if we make a mistake and don't have a correct answer? Yes. We learn the most from our mistakes, so be okay with making mistakes. Be okay with showing your mistakes. You should be proud of them because that's a chance for you to grow and learn. Okay? But these are 3 valid ways that people approach. Alright? Very straightforward. Can we always make a table to represent what's happening? Terrence, it helps pick up a pencil, take notes while I'm going over this stuff. Can we always make a table?
Yeah.
Yes. Now, is that our focus right now? No. We want to use this to help us understand what's going on. In fact, yesterday when I'll get to that in a second. So we figured out what the answers were to A, B, and C, or close to those answers based off that. Then we got a slightly more sophisticated approach, right? We saw that this group took the 151, they subtracted the 124, and so what is this 27 representing?
My minutes.
Nope, what is just the 151 minus the 24? Here's the 151, we subtracted the 24, so what are we getting? Okay, but what is that 27? What about the water? That's the quantity of water that was added since the beginning, right? So they found out how much total water has been added, divided by 9, which was the water per minute, liters per minute, I believe, right? To find out in those 3 minutes. And once again, they took a difference here to find out, hey, 67.5 liters have been added, divided by the 9 liters per minute, so it took 7.5 minutes. Okay, again, we started at 124, so 146.25 liters have been added, divided by the 9 liters per minute, tells me it's 16.25 minutes. So this is important. Where did this equation come from? I mean, you're just reading those equations. How did this inform this equation right here? Okay, so the amount of minutes would equal the liters of water minus 124 divided by 9, but my question really is, can we use what we have up here, how does this get us to this equation? Where in the world do we see or get L minus 124 all divided by 9? Kelsey?
So, M is
M is minutes. I just want you to
Yeah.
focus on the right-hand side.
Oh,
Where did this
okay.
right-hand side come from?
Okay, so L is for liters.
Okay, but why is there an L there? Like, looking at these
Yes.
3 things.
Can you let me?
Oh, sorry, my bad. I'll stop talking.
Gosh. So liters one, you're starting, oh wait, hold on. What you're trying to find out minus starting 1, which is 124,
Okay.
and then divided by 9. I don't know.
Okay.
I was already on the next one, so.
But why? Why are we getting an L right here? Look at these three expressions. Why is there an L here?
Because that's how many
It's
leaders.
a variable.
It's a variable.
Say it over here.
Because we don't know what
We don't know what it is. Look at these three expressions. How do you know we don't know what it is?
Because there's an L there.
There's no L right here.
There's a variable.
How do you know it's a variable? There's no variable yet.
We don't know what we're trying to
You
find.
just know
There's
the
no
leader.
variable there.
124 is the leaders.
I don't understand.
What, okay, hold on a second. What does it mean to be a variable?
You
I'm missing
don't know
it
what it is.
Hey, no.
You know what?
Oh, no. Letter.
Hey.
Able to.
What? This one I didn't.
Verify.
I didn't.
It's able to vary. If it's a variable, right, it literally means able to vary.
Me.
What do you see up here that's varying?
Division.
Did you explain
Yeah,
how you got
probably.
that?
Hold on, say it again,
Did you
Kelsey.
explain how you get that?
Did I explain how to get that?
How to get that? The n equals that.
Like, can I explain it?
No, but
The person who wrote that.
how did?
For
Okay.
what?
Which group wrote this? This is group 3, right?
Which one?
I can explain how.
What?
I can explain it again.
You can explain it?
Yeah.
Okay, explain it.
Okay, so P equals 24 plus 9m, right? Alright, then you subtract 1.
You're looking at the last one over there.
What?
You're looking at this one, aren't you?
Oh.
You're looking at this?
What? What? Hold on. Hold on.
Kelsey, hold on. Hey, look, guys.
Oh.
You
okay.
each had different strategies. What we're trying to do is build up from this strategy to understand this strategy to understand the last strategy. What I'm asking though is, someone worked through this and got this equation, right?
Who?
Group 3 did, right? Wasn't it your strategy that came up with
I
this?
think it was, yeah, I think I remember it was me.
No, we did that one there.
Huh? You did a table? I thought y'all said you did this one. So it was group 2 that did this one.
Yeah, I'm pretty sure.
Okay. So, but Kelsey, this is what I'm trying to explain. I need y'all's attention up here taking notes. Okay? Look. What is a variable?
Something that we don't
Able to
know.
vary.
Sometimes it is something we don't know, but more importantly, especially when there's multiple variables, it's something that is able to vary.
Yeah.
Where do you see something changing?
The L.
The leaders, right?
Yeah.
Which is why we're using an L. But here's what I need y'all to understand. Look at it. Is anything else on the right-hand side changing?
No.
So that's the only thing that should be a variable. What are we subtracting every time?
124.
Okay, so it's L minus 124. That's what I'm trying to get you to see, is that in each of these 3 cases, the number of liters that we have is changing, but we're always subtracting the 124 that we started with, and then what are we always doing after that?
Dividing. Wait.
Dividing by.
9.
So if 124, if minus 124 and divided by 9 stay the same, should it change in the equation?
No.
So it still needs to be minus 124 and then all divided by 9.
Which is.
That's what I'm trying to get you to see. Is that if it changes, it needs to be a. If it changes.
Variable.
Thank you, it needs to be a variable. Okay, there we go. If it's changing, it needs to be a variable. And if it's not changing, it just needs to be whatever number in operation it is. We good with that?
Yeah.
Okay, but this is the strategy I was trying to get you to. Totally valid. But there's a somewhat easier strategy. Alana, I believe you did this strategy, right?
Sure did.
Where did you get this equation to start?
The leaders, talking about the 151.
Yes, the 151, but how did you, I mean, what was the original equation that you were basing this off of? I believe it came from number 1, didn't it?
Oh, you confused me.
What's the equation? There's an equation, you wrote number 1 that you're using right here.
Oh, W equals 124 plus 9M.
Which notice that's equivalent to L equals 9M plus 124. Do you see those two equations?
Oh, is there?
Right? Yeah, there's a commuted property there, but I'm just pointing out that this is what Alana used. She used this equation to get started. And then what did you do with this green equation?
Use the commutative property.
Yeah, we already have that. How did you go from here down to this equation?
Oh, I substituted.
Substitute what?
I substituted. What?
She substituted the equation.
What did you substitute in?
I substituted the 151 liters.
There we go. You see how that 151 is taking the place of L?
Yeah.
Okay. Is the number of liters 151? I know, it's hard that when you come back the next day and you've forgotten some of the stuff that you did. But
Yeah.
notice, are the number of liters 151 right now? And now we have an equation with what? One variable. So what are we going to do to solve this equation? If you don't have this strategy down, under number 2, you should be writing this down now. If you need to, get a separate sheet of paper out so that you can do plenty of work to show how you're getting it. Because it's not just about writing down the equations and the properties and all that stuff. It's understanding why.
Are you gonna go over D?
We already did
You
the.
just did.
We're going to talk more about it in a second though.
So like,
But you see how that's the number of minutes based on the L liters? Isn't that what it asked? Or P liters?
She just wanted to, yeah.
Notice that would be the same thing as P.
so this again, think about binding it downstairs.
No, you should have come to class prepared.
I didn't know I left it.
No, too bad. Sorry. So sad. Alright, notice, and so this is literally what Alana did. Why did you subtract 124 here, Alana?
I subtracted to make it a 0.
Terrence, why are you talking at her when she's trying to talk to the class? Is that respectful?
I was asking.
What'd you do?
I subtracted it to make it a 0.
Notice, what's 124 minus 124? 0. Okay, cool. So why do you subtract 124 on the left-hand
Because you
side?
gotta do it on both sides.
Why?
Nice. That's like property equality.
It's a property of equality, so you're making sure the equation is
Equivalent.
equivalent. There we go, right? We're getting a new equation here, right? But is it equivalent to what we started with?
Yes.
Hey, does anyone recognize that 27?
Yes.
Where did we see that earlier?
Right there. I stay right there.
Oh, look, it was 151 minus 124 was 27. Oh yeah, it was, wasn't it?
Yeah.
And then what did you do after that?
We
Divided by
divide.
Divided by
Nine.
9? Hey, wait, what did we do right here?
The same thing.
Divided by 9.
OG.
Are those things connected, do you think? Are these approaches different?
No.
Yes.
Yes.
Yes. But are they doing the same thing?
Yes.
It's like they're kind of equivalent?
Yes.
Oh, look at that, equivalency showing up again, okay?
OG.
OMG.